Welcome to the derivatives of trig functions. Um, I will forewarn you, part of today's lesson, little video here, is going to be stuff that you probably don't care about, but I care about it, and it's important to me that you know where these trig derivatives came from, and they didn't just fall out of the sky when Newton and Leibniz invented calculus and said, here, there's the derivatives, just live with it. There's a reason that these derivatives are the way that they are. In the end, you really just need to memorize the derivatives of the 6 trig functions, but I want you to see how to get there. Chances are you'll never need to know why in your life, but I want you to know anyway. So, first things first. Quick review of limits here. We have the limit as x approaches 0 of sine x over x, and that goes to 1. And then we also had the limit as x approaches 0 of 1 minus cosine x over x, and that goes to 0. And we're going to need that as we go through and evaluate these derivatives. Now, let's say if I want to find the derivative using sine x, using the limit definition of the derivative and the sum and difference formulas. Basically, I'm saying, well, the derivative of sine x is going to be the limit as h approaches 0 of f of x plus h, which is going to be the sine of x plus h, minus f of x, minus sine, all over h. F of x plus h minus f of x all over h. And I want to take the limit as h approaches 0. Well, normally when you did this, like in pre-calc honors, you went through, the h's canceled out, you plugged in h for 0, you factored, you canceled, but how am I going to factor and cancel this? Well, I'm not. I'm going to use the sum and difference formula for sine. Now, I don't know if you remember this, but there's this sine of a plus b rule, where the sine of a plus b, God, that's terrible writing, where the sine of a plus b, I'm going to type it because that's quicker, the sine of a plus b equals sine a cosine b plus cosine a sine b. And because I'm not in class with you, I have to sing on the video here. Sine a plus b looks like this. Cosine a plus b looks like this. And here's how the song goes. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. My favorite thing ever. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. And really that sine, sine, sine is because this thing is SIGN, a sign change. So when we come down here, these sum and difference rules are going to make a difference right here. We need the sine of x plus h. So that is now going to turn into the sine of x. The cosine of h, sine, cosine, cosine, sine. And then I have minus sine x all over h. And I'm taking the limit as h approaches infinity here. Now, I'm going to rearrange this a little bit and take the limit as h approaches, not infinity, h approaches 0. And I'm going to factor out sine x. So I'm going to say sine x is actually being multiplied by cosine h minus 1. And then I still have a plus cosine x sine h on top. And that's all over h. And then I'm going to write this as two fractions. The limit as h approaches 0 of sine x over 1 times cosine h minus 1 over h plus cosine x sine h over h. So over here, as h approaches 0, cosine h minus 1 over h is that limit that was back up top here. That was 0. So I have 0 times sine x. Then cosine x isn't affected by the 0, but sine h over h right here goes to 1. So this becomes cosine x times 1, and the value of our limit is cosine x. The derivative of sine x is cosine x because of sine, cosine, cosine, sine. Inside this limit guy, sine becomes cosine. Long story short, you could also prove that the derivative of cosine is negative sine and use much the same method as above. The reason it's negative sine is because of the cosine, cosine, sine, 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 and that sine in the middle gives you a negative. Now, last but not least, if I want the derivative of tangent, I can use the derivatives of sine and cosine in conjunction with the quotient rule. So if I want the derivative of tangent, that's the same as taking the derivative of sine x divided by cosine x. And if I quick do the quotient rule, low d high minus high d low, all over low times low, I get cosine times cosine minus sine times negative sine, all over cos squared, which is going to give me cosine squared plus sine squared all over cosine squared. Well, cosine squared plus sine squared is 1, and 1 divided by cosine squared x can be rewritten as secant squared x. So the derivative of tangent is secant squared. And now for the moment you've all been waiting for, memorize this and your lives are complete. You don't need to do anything else, just memorize this chart and everything's fine. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. Using quotient rules, we can get to the bottom three as well. The derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant times tangent. And the derivative of cotan, negative cosecant squared. Oh, God, how are we going to remember what's negative and what's not? Easy. The trig functions that start with c have a negated derivative. Sine doesn't start with c, positive derivative. Cosine starts with c, negative. Cosecant starts with c, negative. Cotangent starts with c, negative. That's it. So when we come on the back here and we just take some derivatives, you just need to memorize those 6 from the front. So I'm going to go through and do a couple and then pause, have you practice, check back, and we're done. Easy peasy, quick notes. So f of x equals x squared sine x. Well, this is a product rule. It's x squared times sine x. So f prime is going to be the first times the derivative of the second, derivative of sine is cosine, plus the second times the derivative of the first. And I'm going to rewrite that. When we have trig functions, we like to put everything else in front so we don't get confused and think that this is like x times 2x, because technically that has like parentheses around it. So I'm going to rewrite it as 2x sine x. Oops. There we go. Wow, that's a terrible circle. I'm going to do one more over here, and then I'm going to leave you to yourself to try the rest. Y equals 5 secant x plus tangent x. Well, that's easy. Y prime is going to be 5 times the derivative of secant, which is secant tangent. And then the derivative of tangent is secant squared. Easy peasy. That's it. All right, I would like you to try the rest. I'm going to do them, then make them magically appear and go over it. And then we'll come back, chat, and we'll be done with trig notes. Super quick. All right, like magic, let's go through these things. So if we take a look at these first two, all right, 3 and 4, cosine x over x, I'm going to do a quotient rule. Low d high minus high d low. And we end up with this guy down here, negative x sine x minus cosine x all over x squared. Take a look at the next one, 1 over theta. I'm going to think as theta to the negative 1. So negative theta to the negative 2 plus, because I've got this minus and the derivative is negative, 4 cosecant theta cotangent theta. All right. Moving on to the next pair here. On the next one, we're just going to do a power rule here and then the derivative of tangent. No big deal. Over here we have a product rule. The first times the derivative of the second plus the second times the derivative of the first. This is just begging to be simplified, so I would rewrite it as secant cubed plus secant times tangent squared. All right, like I said, quick, I'm going through these here. Number 7 and number 8 I really want to talk about, so we'll do these kind of one at a time. Number 7, we have another product rule. Okay, and if we take a peek at number 7 here, my derivative, 2 cosine times negative cosecant squared, plus cotan times negative 2 sine t. So then I kind of rewrote this and got negative 2 cos times cosecant squared minus 2 cos. And I figured, you know what, that's a lot of negatives, and I can kind of pull out a negative 2 cosine. So I did that and was left with this behind. You don't have to simplify it this much, but a lot of times when we have multiple negatives that we're afraid we're going to lose, we like to factor it out in front. Now, last but not least, what's this f14 mean? Well, that means take the 14th derivative. When you see something that looks like an exponent with parentheses, it's telling you to take that many derivatives. So if I want the 14th derivative of sine, I said, okay, the first derivative, cosine. Second derivative, negative sine. Third derivative, negative cosine. Fourth derivative, sine. And I'm back to the beginning. So every fourth derivative brings it back to where it started. So if I need the 14th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, my 14th derivative is just negative sine x. Okay? If I wanted that to be f of the 315, I would just say, okay, what's the closest multiple of 4 in here? Well, 312 is the closest multiple of 4. There's where the multiple of 4's go. So this is the 312th derivative, 13, 14, 15. That would be negative cosine x. And for our jokes for this episode, the first one is, what's invisible and smells like bananas? What's invisible and smells like bananas? Monkey burps. And what's invisible and smells like peanuts? Elephant farts. I know, those are jokes that my 6-year-old loves, so I thought you might like them too. Have a good day.